Well, first of all, human milk is a unique milk. It is different than the milk of any other species, and you can see that in the fatty acid composition of human milk. So first is its part in the whole fat composition. So about 4% of human milk is fat, and this makes up a major component of the infant's energy intake. But the actual composition of what is in that fat is different than the fats that you would give from a milk if you were giving cow's milk or goat's milk or any other kind of species. That is, the milk made for the human infant is distinctive. And it's distinctive in a couple of different ways. One is what kind of fatty acids specifically, and in another way is how those fatty acids are put together, if you will, how it's constructed as part of a triglyceride molecule, which is the major form in which the fatty acids are structured in human milk. So in terms of how human milk is distinct from other species, if we take the cow, for example, which is our major source, or goat, these are ruminants, and they have a certain kind of diet, and they produce from their own food source a certain kind of fatty acids. And typically those fatty acids are much more short-chain fatty acids and certain structures. In human milk, the fatty acids are a wide variety, beginning with oleic acid, which is a monounsaturated, followed by palmitic acid, which is a saturated fatty acid, and followed then by, most abundant after that, is linoleic acid, which is an N6 polyunsaturated fatty acid. So these are major three, and they're pretty long. They range from chains of 16 carbons to 18 carbons, and much longer typically than you would see produced by a cow. But also, there are other fatty acids. Certainly there are fatty acids such as the omega-3s fatty acids, we know to be very, very important. And altogether, they are placed in a conformation as part of a triglycerides. And that's the way fats are produced in human milk. And how they're positioned within a triglyceride molecule also, we begin to see, can also matter. So in the triglyceride molecule, it puts together 3 fatty acids at a time, like a little package, if you will. And in that packaging, it depends on whether it's in the middle or on the outside in this group of 3. Well, if it's in the middle, that's called the SN2 position. And for human milk, it differs from cow's milk in terms of which fatty acids show up there in the middle position and which are in the outside position. And that might sound pretty unimportant, but it turns out to have an important physiologic effect. So, as I mentioned before, the most abundant fatty acids in human milk are oleic, palmitic, and linoleic in that top 3 order. And so typically in human milk, you have the one that is the most abundant saturated fatty acid right in the middle of that 3 in a triglyceride. And on the outside, you have the unsaturated fatty acids. And this is a human milk composition in particular that you don't see in cow. And that helps with absorption and digestion so that the baby is better able to digest and utilize all of the nutrients. The fat is better able also to utilize calcium, which is not clearly a fat, but a mineral. And why that is because this palmitic acid, which if it's put in the N2 position, it is better absorbed If it's put on the outside of the structure, it is not as well absorbed, and it tends to conjugate with calcium to create calcium soap-like structure. And that tends to make stool harder. It may end up with a more colicky infant, uncomfortable infant. And so there are several different elements of this that make human milk fatty acids distinctive. And we find that generally worldwide, human milk fatty acid composition is relatively similar. You can see the structure looks very different if it's human than if it's cow or any other species. But even so, within human populations or cross populations, there are differences. And some of the differences that have been found, that we've found and others have found, is in fatty acids such as linoleic can differ. Like in China, it's much higher than in many other populations, probably because of dietary influences. Also in coastal populations, say in China would be Shanghai or other coastal populations where people eat a lot of fish, you have much higher DHA, omega-3 fatty acid, which could have health benefits. In some populations, such as the city I'm from in the United States, which is Cincinnati, Ohio, we have very low DHA levels in human milk, and we don't eat much fish. And we may eat more processed foods, more fried foods in some populations, and we have more trans fatty acids in milk. So population to population can influence by maternal diet, can be influenced somewhat by the genetics of the population, because mothers can also synthesize some of these from their own bodies and the enzymes that they produce from their genes. So another thing about human lactation is that mother's milk is very dynamic fluid. I like to refer to it as a living fluid. And so it changes within a feed, it changes over the course of lactation. This is normal and natural and healthy. So for reasons we don't yet understand, human milk composition also changes as the baby gets older. Something to keep in mind. What do these differences in fatty acid composition do for infant health? And that is an important topic of ongoing research, and we actually know less than we should about that. We have only just come to the point of being able to describe fairly clearly how variable human milk composition can be, and we've just begun to understand how that might impact infant health and what we need to do for breast milk substitutes or infant formulations. But one of the things we do know is that omega-3 fatty acids in human milk are very important for neurodevelopment of infants. For example, eyesight or visual acuity, much improved with higher DHA levels. Also, other aspects of neurodevelopment that are improved, psychomotor development, for example, has been shown in multiple trials to be important with, to be increased with DHA levels. So that's one fatty acid where we know something about it. There's other kinds of evidence about the other fatty acids, such as linoleic or trans fatty acids or other things, but there are more than 200 different fatty acids in human milk. And we're talking about a fluid that is fairly complex. Another domain where we've learned more is this palmitic acid in the SN2 position. Meaning if palmitic acid, which is very major saturated fatty acid of human milk, it's always abundant. It's an important fatty acid in all milk of humans. But what position it's in the fat molecule, the triglyceride molecule, seems to impact the ability for fat to be absorbed and for calcium to be also as well absorbed as it might be. So this has been a big topic in infant nutrition, with different people looking at this. And so there have been some trials of enriching infant formula to be more like mother's milk in this structure, and compared to using another approach to having palmitic acid, which is using palm oil. And the trials that are been comparing this show clearly that you can improve calcium absorption in a baby if the fat is structured in this SN2 position for palmitate. And you can increase also fat absorption. And there are a number of trials showing this. We do know that human milk has a certain composition, and that is a very good guide for what infant formulation ought to look like for the same, and companies are trying to follow that. And so after we learn the composition, which we now have, we then try to do trials, and it's important for more infant trials to be done of comparing different comparisons, for example, this SN2 question. It's also critical that we learn more about some of the individual major differences in fatty acid composition between, let's say, the milk of a mother in one part of China versus another, or one part of the United States versus another. Is it important? Is there an ideal fatty acid composition? How can mother's diet be changed? Is often asked, like, how do I make my milk to be ideal? A mother might ask. Well, at this moment, we don't really have that kind of data. We don't know what ideal really is. What we can say is that having a diet that's healthy, full of DHA, for example, or omega-3 fatty acids, good for the mother, good for the baby, and we need to learn more about other things for moms. And when infant formula is being made, structuring the fatty acid composition more like mother's milk is a good start, but we need more trials of comparing these formulations. And right now, having an issue of palmitate in the SN2 position seems like a good thing, but is not a definitive recommendation. To summarize some of the most important recent insights, I think those insights include the idea that there really is a core human fatty acid composition that's reliably present across many populations. But there's also variation, and that variation can be affected by diet of the mom, can be affected by the genetics of the mom, unbeknownst to her, perhaps, and over lactation. So that's now become quite clear. And it's now clear also that there are certain fatty acids that don't seem to change much from population to population and are not much influenced by dietary differences. The ones that are really different across populations include omega-3 fatty acids, as I mentioned, linoleic acid, which is a polyunsaturated fatty acid, and a set of other fats, such as the trans fats. And we only know this after a lot of comparative studies across populations. And in terms of the health outcomes, we now have trials of at least the omega-3 fatty acids. And then that has narrowed us to understand that there are certain benefits from having the omega-3 fatty acids in infant nutrition. And the other thing that's been studied that is the most up to date is really how much work there has been on the position of the fatty acids when it's being structured. In mother's milk, naturally, most of a mother's milk has it structured in a particular way. And that's not easy for companies to reproduce and to be like mother's milk, because cow's fat is not like that. So it has to be done specifically for infant formula. And we now know that very clearly that if you put this particular saturated fatty acid the way mother's milk does, which is palmitate in an SN2 position, you can improve calcium absorption and increase fat absorption. But we're still trying to learn. We realize that we need more trials to look at a lot of other health consequences, but we have enough evidence to say what may be happening. It's probable. And what probably is happening, or appears to be happening from several studies, is reduced crying and colic, and therefore having a more comfortable baby, if you will. And that's an important, this is a paper that was recently issued by ESPGHAN, Committee on Nutrition, and that helps to give us guidance that we still don't know what we need to know ideally, but that we're making some progress in understanding and that we need more research. So in general, infancy is so important and mother's milk is so important. And we need to continue studying it and continuing to see what health benefits it has, and then how to increasingly, step by step, improve infant formulations. Mother's milk is the best, and that's the number one take home, I think, that I would like for everybody to know, is that no matter what, we don't know how to make any formula to be exactly like mother's milk. It's not possible. And we're just step by step trying to improve.